Hi Adam. I wanted to show you a quick movie to explain why I'm asking all these technology questions. It's not just about Logger Pro, although that's a huge part of it, especially in chemistry, but also in physics. Another part of it is this program that I've been using this year that I've decided is really great because it can provide for problem-based learning in physics. And it allows kids to be able to manipulate and visualize different things. You've probably heard of it. It's called GSP, which stands for Geometer Sketchpad. And so I'm making a quick screencast to show you an example of what I'm using with this year's 9th graders that I'm teaching as we discuss breaking down vectors into their components. It's a really hard concept for kids to get, but this is pretty cool. So if you look here at the intro, it says, "This week in class, we have been analyzing the motion of an object on a ramp. Mrs. Smith has built this demo to help you understand all the concepts that are part of a ramp problem." So it says, imagine a box sitting on a ramp that has no friction. The box is sitting on a scale that measures the weight of the box in newtons. There is a rope that is being pulled enough to keep the box from moving, which is balanced. The box is represented by a point, and I've got this point and I'm moving it right here, on the ramp below. So what kids can do is they can actually manipulate different variables of this ramp problem. So they can raise the angle of the ramp, and if you look over here, the ramp angle is measured there. So we can measure the angle of the ramp. They can measure the force of gravity, which is this one right here. But also what's measured, I'm going to make it big to show you, is the normal force, which is the force of the box, and the force of the rope. So this problem literally shows how the X and Y components add up to be the resultant. And so what I've done is I have asked questions down here that require kids to manipulate certain parts of the situation. So in this first set of questions, I asked them to manipulate, I'm going to make this smaller, I asked them to manipulate the ramp height and then look at what happens to the components of the force. And then I've asked them to devise a rule. What is the rule that happens as we move the ramp height from 0 to maximum would be 90 degrees? And what I'm looking for here is that kids can understand that when it's 0, like this, the entire force is straight down. It's all vertical. It's all part of that one component. There are no components, basically. But as you raise, part of your force then becomes a part of this horizontal component as well as the vertical component. Anyway, over here, a little science lesson for you, Adam. Over here, I've asked the kids to keep the ramp height stable, but change the weight of the box to then discuss how does the weight of the box change the different components. And finally, my last question down here is, what happens if you keep everything the same but you just change the position of the mass on the ramp? The idea is to show kids that it's the angle we care about and it's the weight we care about, not where on the ramp it is. So, anyway, this program is called Geometer Sketchpad, and I'm right now looking into getting copies of it. I'm not sure if there's costs or if you guys have even had it before or how much a license would cost. I'm kind of looking into that, but I've been using it this year, and looking at the essential questions that Brianne sent me, I'm really excited because I think that I'm going to be able to completely integrate this into the everyday class. And so what happens is kids are going to be able to manipulate these variables, and then we can reinforce that with labs and with other sources of information. But I think that there's something to be said about the way kids can visualize this. Anyway, second, real quick, I don't want to make this video too big. Here's another example. I'm going to send you a screenshot of it, but it's basically an airplane and wind, and we talk about the resultant vectors, so it's all completely interchangeable. So kids can discover, depending on the direction of the wind, how do vectors add, how do they subtract, things like that. So I just wanted to send you a quick video so you know why I'm asking all these questions about technology and figuring out whether this is something I can do, because I really think it's an awesome way to have an inquiry-based classroom. Anyway, I hope you're having a great day, and I just want to share a little bit of a good idea that I've been having and give you some context for why I'm asking so many questions. I'm normally not a pain in the butt, I promise. Enjoy Colorado, enjoy the mountains. Bye-bye.